Check.
All right, thanks everyone for showing up today. We're going to have Rahil Madak, one of the professors here at the University of Minnesota, talk about shift share IVs. Let's welcome Rahil.
Awesome, thanks guys. Yeah, so I am here to distill Bartik or shift share IVs into plain English. So probably many of you, if you're here, you've already seen some of the recent papers. This is a very new field. There's really only like 3 or 4 papers on the topic. Mostly they're like econometric theory papers, which are extremely hard to digest, for myself included. So what I plan to do today is not really go through any of the derivations or asymptotics or any of the fancy stuff. I just want to just like make this into like a how-to manual of how to think about shift shares and how to implement them and what the identification assumptions are. Thankfully, in the last like 3 weeks, a handbook / like FAQ was released, which probably most of you have seen as well, by the same authors who write the fancy stuff. So they wrote this like paper for the Journal of Economic Literature, like distilling everything in English. There's like more equations in it. So some of this is I'm drawing from there, and then some of it is like my own interpretation of papers, and then like some of it is from my research. So like I said, I'm going to be more conceptual, not mathematical. If you have mathematical questions, I'm trying my best. And you can just enter them to me. We'll make this more conversational. Okay, so I'll start by saying that I think shift shares have actually been around much longer than we think. So most of us think it's been around since like the Bartik paper came out in 2020. But it's been around for a lot longer than that. All it really is just like, you know, an aggregate shift that's like apportioned down to lower levels based on exposure to that shift. And that's like not new, right? These exposure designs have been around for a long time. So I was thinking back to like the first time that I ever saw one of these, and I didn't even think of it as a shift share at the time. But there's a paper which maybe you've seen before. It's called Dams by Esther Duflo and Rohini Pandey. It's pretty old. And they're looking at what's the impact of dams on poverty. I read this like a long time ago for a project that I was doing. And what they want to do is just instrument the amount of dams built in a place based on the river gradient. So the idea is that depending on what the slope of the like rivers are, that has engineering implications for whether you can build a dam. Makes sense. So all they want to do in their first stage is just regress the number of dams on the river gradient in a district I. And that's it. And then we have state fixed effects and district. And you see what the problem is. Well, I mean, the argument is that like the river gradient is exogenous, because like the slope of the land is determined by the altitude.
But like, don't people move to places based upon the slope of the land?
Probably, but how would that relate to
Like, if more people move to a place, that might be a place that's less likely to have a dam because people don't want their houses flooded out, or vice versa. Maybe a place that has more people, they need irrigation more, so it's more likely to build a dam.
Okay, I see your point. I was going for something simpler, which is just that there's a district fixed effect, and the river gradient is also at the district level, so then you can't do this regression.
Yeah,
but I mean, I like what you're thinking. But this won't work because there's a district fixed effect, and this is fixed. The gradient can change over time. So what they did, which was kind of cool, is instead of having the river gradient just on its own, which won't work, they interacted it with the number of dams at state level to like add time variation. And then this beta here becomes the fraction of the dams built in a state that are like built in a district depending on how much of the river gradient. So it's like the proportion of the total number of dams in a state allocated to a district based on that district's river gradient. So this is like a cool trick to give, to get a beta when you also want to. It just adds this time. The problem is that this number of dams in the state is just summing up all the dams, across all the districts. So this is by construction endogenous, because this is a sum which includes this, right? And so what they did was they decided to do what we now call a shift share, but at that time they just came up with a clever trick and they said, why don't we just take the total number of dams built in India, is where this project's taking place, and then multiply it by the share of dams in the country built in that state before the study period. So they would say, okay, 100 dams were built in this year of the study period in the country, and one state was a really popular dam building state before the study period. So let's just apportion them down to the states based on its pre-period share. And that way, this becomes, the outcome of some combination of a national level variable and these pre-period shares. And then that predicts the number of dams in a district, but it's not just summing it up like this way. It's giving us like a predicted value for the number of dams in the district based on these national values. And so that was like a trick that they did to get around this problem with these two big correlated districts. So I saw that and I was like, oh, that's a pretty cool idea. And then now cut to 20 years later, we have shift shares, which is what I just said earlier. It's this aggregated shocks apportioned down the lower levels. And that's exactly what they did in that paper. Yeah, so that was the first time I ever saw shift share. Now we're being a lot more formal about it. In that paper, it was one line, and that was it. And there was nothing beyond it. But now we're getting kind of deeper into the account of the case. So I'll start with defining it, and then we'll get into the identification assumptions. So as I've kind of been alluding to, the shift share is just some kind of weighted combination of common shocks, meaning that it's an aggregate, the shocks are happening at some high level, and those shocks are being apportioned down to lower levels based on how exposed each of those individual units is to the shock. Okay, so we call those heterogeneous exposure shares, and then we have these common shocks which are at a higher level. And then our instrument is just some weighted sum of the shocks times how exposed the underlying units L are to that higher shock. Okay, so if the shock is like some kind of trade shock in an industry, then the share is how much of that industry is present in a given location. Okay, the shocks and the shares are varying at different levels, and our goal is just to use this generated instrument to estimate trigger effects like always. So it's nothing more than that. So the instrument still is the same. It's just that this instrument is built up from two underlying pieces instead of just having one variable for the instrument. That's it. Okay. So once we've built up this shift share instrument, we're now just going to estimate this beta in the same exact way as it is. So we have a model where we just want to know the effect of X on Y. X is endogenous. We're instrumenting X with the Z, and we're back to the same rate. That's the only difference is now the Z is the combination of these two. It introduces some complexities, which we'll get into in the next slide, but for now, the setup is the same as what you've been learning since probably. Yeah.
So there's a question about the sum is over shocks n,
Mhm.
but the shock is the sum of the shocks after we think the start of the shocks, or there's some baseline level which is independent, and then you sum. So like if you went that one slide back, right, they start with this baseline level of the shares,
Mhm.
and then it's multiplied by these shocks.
Yeah.
Do we include the shocks that happen at baseline? So the like effects and initial.
Yeah. Yes.
Okay.
Yeah. You have a choice whether you want your shares to be the first period or the pre-period, but your like shocks will start from one period after if the share is the base period, then your shocks will start from the next period.
So it's the sum of, the way I read that is sum of all the shocks after the base period multiplied by the initial level of share.
Yeah.
Okay.
If you choose to make your shares the pre-period values, you could also make it the t equals 1. You could use that as the share, and then your study period will now be from t plus 1 onwards.
Okay.
Does that make sense?
Yep.
Because the idea is going back here again, it's like if state dam building is just the sum of all of the districts, then this becomes part of this, so it's endogenous. That's why here the shares are from before the study period started. So when we multiply this by the national amounts, then it's like converting the national down to the local based on shares that were plausibly exogenous because they were before the study period started. So you want to start the analysis of the weighted sums and all that stuff after the pre-period shares. The pre-period, now your shares don't have to always be the pre, like they don't have to be um like some lag value. They could be something else. I'm just using that as an example. Okay, so all I wanted to say here is just that we are just starting with a different definition of the instrument. It's no longer just one variable. Now it's a combination of the shocks and the shares. But once we've found that instrument, we're just back to the regular identification assumptions. I'll give you a couple examples because I know I'm just talking about shocks and shifts right now, or shifts and shares. So the most canonical example you might have seen in some of the literature, and one of the first times it was really analyzed in detail, is from like an old labor paper. So they're trying to estimate the labor supply elasticity. So they just want to know the effect of employment on wages. Employment goes up, what's the effect on wages? Obviously, there's a big homogeneity problem because wages are determined in equilibrium. So we don't know if it's coming from shifts in supply or demand. We just want some sort of labor demand shifter to give us exogenous variation and employment. Okay, so what they do is this shift share, where they take the national growth of a certain industry. So let's say manufacturing. They say manufacturing in the country is booming. And then they apportion that down to the level of a region based on how important manufacturing is in that region. And they do that as a weighted sum across all the different sectors. They'd say manufacturing, this is the national trend, and manufacturing is 2% of the labor force in this location. Then there's a shock to services. Services is really important in this place. There's a shock to farming. That's not important. And they take the weighted average of those shifts and the shifts. Okay. And their assumption here is that now if we were to take the predicted value of employment based on this shift in the share, now we have variation in employment that's only coming from these national shocks. And because the local labor market can't affect national trends, it's plausibly exogenous. So again, the more intuition would be like, you know, if you're a manager or something at a company, it's a manufacturing company, you see that the manufacturing industry is booming, you want to hire more manufacturing laborers. So that's like their exogenous shock to labor demand. Okay. Another example, which I think is a little bit more intuitive for me, is from a recent paper on migration. Migration is kind of a new area where a lot of people are using shift shares, but they just want to study the effect of migration into a place on firm activity in that place. The more immigration, what's the impact on firms? It's endogenous, obviously, X, because migration is going to affect firm activity, but firm activity is going to attract workers, so there's a push and pull issue. So they're going to try and isolate just one of those streams, the push and the pull. So what they do is they look at shocks to agricultural incomes in the origin where these people are immigrating from. So that's like a push shock. So they say, okay, if agriculture is doing really badly over there, then they're probably going to leave that sector and migrate to this. And because agriculture shocks are in some distant destination, it's plausibly orthogonal to local farm activity. Okay, so they'll say for their shift share, there's some shock to agricultural incomes in some origin, and then they use as the share the number of people from that origin in that destination. So it's kind of based on this idea that you're more likely to migrate to a place where there's more people. Okay, so that's their shift in their share, and they'll do that for every origin place. So number of workers coming from this one place times the share of workers from that place in the destination plus workers coming from the other country times their presence in this location plus, you know, and that gives us predicted migrant inflows into a location only based on the stream coming in based on agricultural shocks, not any other reason. And then that gives us a nice instrument. Okay, so those are kind of two good examples of what this looks like. And then once we have predicted migrant inflows, we can then instrument our X. Okay. So I'm going to, okay, I'm gonna quickly go over like how to build up the shift share, like just right from the beginning, and then I want to get into some of the identification assumptions, which I think is more important. But this, all I want to show here is that like you don't have to be clever to come up with a shift share for any variable. If it's endogenous and it has spatial and time variation, in theory, you can decompose it into a shift share. Any variable. Whether it works or not is a different question. But the point of this is just to say that you can always decompose a variable that has spatiotemporal variation into a shift share. And then it's your job to do that decomposition and then decide whether it works or not. Okay, so the way you would do that is you can just take any variable. I'm going to call it XLT. So L is like the unit, the spatial unit, say county, and then T is time. Okay, so for an examples case, let's just let that be crop output in some period T0 equals 1. So then we know since there's only 2 periods, the growth in crop output is just, it's value in 1 minus 0 divided by 0. That's just the percentage change in crop output. Now, the idea here is that crop growth is a combination of a bunch of different crops growing, and there's some sort of combination of all those different crops, which gives us total crop growth. So we can decompose that. We've already done the time part, but now we want to do the across crops part. Then we have kind of the basis for a shift share. Okay, so for any given crop, let's say N, we can just say this is the percentage change in that crop. So that's this for crop N. And then we know the share of that individual crop at time 0. That's like the baseline in this case. So that's like the amount of that crop divided by the total crop output in that period. So this is the share, and that's the share. And so we've done that just from this one X variable, and that's the endogenous variable. And we've been able to now split it up into its share and the shift. And so what you need to do is just replace this with some sort of global shift or some sort of other shift that you can replace here and keep using these shares so that you can have an instrument. And you can do that with any variable. And so in this case, one example would be like, I don't know if this works. I was just trying to think of something, but if you were to have like degree days that was crop specific, so if different crops had different tolerances beyond which they start dying, then you could use like the number of degree days above a threshold, which varies at the crop level. So that could be like a shift multiplied by the shares of that crop. So if there's like a big weather shock that's kind of specific to one crop, and that's a really popular crop in a region, then they'll be devastated. And then you can use that as a shift share. The idea is that you can just take your endogenous variable. If you don't know what to do with it, you don't have a good research design, but you still want to write this paper, you can just try this exercise, and then hopefully something works out for you. Okay, but none of this will work without your identification assumptions. So let's go through that real quick. Honestly, I think this might be the most important slide for all of this because none of it works without the right identification assumptions. We cannot use the standard ID assumption. That's like the main takeaway. And unfortunately, that kind of destroys most of what we want to do here because the standard ID assumption assumes exogeneity at the unit level, right? It's like every individual unit in your data, whatever row of data you have, there should be no correlation between the instrument and the residual, right? But in this case, that doesn't happen because now our instrument isn't just one variable, it's a combination of this aggregate and these lower level variables. And so all of the lower level nested units are exposed to the same shock. And so there's these dependencies by construction because you might have multiple crops that are going to be hurt by the same degree day threshold, right? Or you might have different regions with similar manufacturing shares that are all going to get hit by the same manufacturing global decline or something like that. And so unfortunately, this doesn't really hold anymore because the observations are not, we can't use the IID assumption. So what do we do in that case? That's what I just said. All we have to do is just kind of do some magic, like you said, and we will have to make the assumption that on average, across the full sample, across all the shocks and across all the units within the shocks, that on average, we can have the uh, the correlation between the instrument and the error converge to 0 on average. So what that means is that even though some manufacturing, places with a lot of manufacturing, if there's multiple locations with the same shares, all exposed to that manufacturing shock, as long as there's enough other types of shocks that are happening at the same time, then once we aggregate it all together, on average, across all of your sample, the instrument should be assigned random. That's what this says, in my attempt to explain it in English. So if you have enough shocks, and you have enough data, then even if some of the shares are similar and they're exposed to the same shock, as long as there's enough other shocks, because it's not just manufacturing, it's all of the other ones. We're summing over that n. Then as long as there's enough of the other ones, then we should, on average, this should converge to the same standard assumption. Okay, so all you have to do, if you just divide by L, it just means that now not just the unit level Z is orthogonal, but the average of the combination of the S and G on average converges, and that's using the law of large numbers. So I'm not going to go through the econometrics, but if you look at the, I think this is in, I have it at the end, all of the resources, but this is proved in one of the recent papers, and it just says that we can still invoke the standard IV assumptions. We just have to assume that there's enough variation in enough number of different shifts. Okay. And I'll go over, if it sounds like magic, I'll go over some different tests that you can do to ensure that this works out. This is just saying everything I said in a much more simple way. Yeah, so in standard IV, each unit gets an independent instrument. In our case, they don't, because they're correlated. But if we average over enough shocks, then we're good. Okay, so what I should have put here as a segue is that this is the G times the S, right? Like this is the shock times the share. So this, we have two pathways to determine whether this holds. There can be exogeneity through the shift or exogeneity through the share. And it's up to us to decide whether this condition holds via either pathway or both, but it's very unlikely to be. So if we want to make sure that this is 0, shift of this equal to 0, that means that either the S or the G should be plausibly exogenous. Okay, so let's start with the shares being exogenous. This would be kind of the easiest case, right? Because if the shares are exogenous, then that means that by definition, there should be parallel trends within each of the different shocks. Because wherever the shock is being assigned is random. So if you are a place with like high manufacturing and therefore you're really hit by this like global manufacturing boom, you being a manufacturing place is random in this setting. And so in the absence of that shock, that location should be on the same outcome path as a place that had low manufacturing intensity. Okay? So if the shares are exogenous, then this is very easy to prove because that shock is being assigned based on a lottery, essentially. And so what I just kind of described is with the parallel trends assumption, that holds for every shock. So not just manufacturing, but also services, or if we're in the migration example, the place receiving migrants from a certain origin, it's random that they're choosing to go there. And so without that inflow in that location, they would have had the same firm outcomes compared to a place that has less people from that origin. That's what this is saying. And so you can essentially, so the estimator in one of the papers that I'll kind of list in my resources, they prove that the shifter IV identification assumption is the same as if you were to pool difference and differences over all of those different ends. And that's like a really nice, pretty result. You have a question?
Yeah, so like in my brain, when I was thinking about this, I was thinking about it in terms of oil. Because I thought to myself that like the location of oil discoveries is kind of exogenous. Where you find oil, I thought that seems plausibly random. So when I thought about it that way, then I was going, okay, I can use movement in the price of oil, assume that my shares are exogenous and roll with it.
Yeah.
The way that you're setting this up though, I need to assume that it's gonna be exogenous to all of my shocks, like, and also that all of the different shares need to be exogenous, or can I just assume that oil is exogenous, but the rest of the industries might be endogenous?
So in your example, are you only focusing on oil or are you using variation in booms from other sectors?
Just oil.
Okay, so then you're not worrying about
Yeah.
the other
okay,
sectors.
so
So in
I
that
only
case,
have-
in that case, like your weight is 1
Right,
on oil and
yes,
0
yes,
for
yeah,
everything.
because I only got one shock.
Yeah.
Only have, okay, cool, that makes sense.
And it still works in this setup because, like I said, you're assuming oil is 1 and everything else is 0.
Yeah,
But then your assumption is that like without the oil shock, that place would become a place with a high, well, in your case, then what is your share? If it's like how suitability
something like
for
that.
oil? Okay.
Yeah.
So yeah, you'd have to just assume that places with fewer and more oil wells would have trended similarly
Yeah.
with and without the shock.
That was what I thought, my assumption. Okay.
Yeah, but that's a tough one. This is a different thing.
Yeah.
But it's like being suitable for an oil well, but actually building an oil well are 2 different things.
Totally.
So it's conditionally conditional on there being a like deposit,
Somebody that discussed, yeah,
but then choosing to drill
yeah.
is an
it's not-
exogenous decision.
Yeah, exactly.
Still sounds cool though. Okay, and then this is just something that I wanted to put there because I've been hammered on this from like referees, but an issue, even if you think that your share is exogenous, another problem is that if there are other shocks that will affect your outcome through the same share, then you are screwed.
Oh, cool.
So if oil is correlated with like just general natural resource commodity booms,
Yeah.
which includes like forestry and something else,
Yeah,
and that also affects your outcome. I don't know what your outcome is
yeah,
through like
Yeah.
oil deposits
yeah,
or whatever deposits, then you can do it. Because your exclusion restriction won't work.
Yeah.
So you can control for those if you want. But that kind of breaks all of this down. Okay. So the example here, which was put in some paper that I saw, which is kind of interesting. I think I've already given an example in here, but it's sort of similar. So it's like here they are looking at in this paper from the 90s, they want to study kind of like hiring of immigrant versus native workers and what the elasticity of substitution between the 2 is. So they're looking at the effect of relative employment between native and immigrant workers on their relative wages. They want to know like if there's more immigrants that come in, how does that affect the wages in the sector? So they use this shift, which is from like a shock to immigration coming from refugees fleeing the authoritarian regime in Cuba. And their share is the lagged number of Cuban workers that are already in Florida, across different parts of Florida. So the idea is like places that are already pretty Cuban, you're gonna expect a bigger inflow of immigrants, and that's gonna have a different shock to wages versus native workers compared to a place that doesn't have any Cuban workers, because there's gonna be a lower influx of people, so that's your control. So that's what they're doing here. But the assumption, obviously, this isn't gonna work here, but is that in the absence of that inflow, places with more Cuban and less Cuban workers are on similar trends. Right, but that's probably not true, but for the sake of the example, I just want to give the intuition of how this would work. But like in your case, this is only the influx of Cuban workers.
Yeah.
So Cuban, this is really bad notation. It's not Cuban for the good one. It's like the weight in the shift share. So the shift here would just be the influx of Cuban workers, or N is Cuba. So that'd be 1. And then we would say you would add the number of workers coming from a different country times their share across Florida, plus, in this case, it's just 1 0 because it's only Cuban workers. And so what this is going to do is basically give us a diff and diff that's pooled over all of the different regions. And so that's where they show this equivalence result that the shift share is going to identify, the beta is going to be the same thing as pooled different beta. And I'm deriving it here. If you're going to actually use this approach, this wouldn't be a bad idea to like show the equivalence, because it makes things a lot easier, and then you can start using the different diff language, which I'm personally more comfortable with than the shift share language. I won't go through this in detail, but the idea is just that if you just take the standard exogeneity condition for the validity condition for an instrumental variable, so that's just that the instrument should be uncorrelated with the error term. You know, that's the S times the G, that's how we define the shift share. This is linear, so you can just pull the summation out and put it out there. And then, again, I'm not going to go through the details, but you can use the law of iterated expectations on this. And that's just going to give you this equation here. So here we have the expected value of the shift and the error term. This is from the law of iterated expectations. And this just gives us this result here because we have this we already know is equal to 0 because we assume the shares are exogenous. So this becomes 0. So that means that if we just take the sum over all of the different shares, sorry, over all of the different units at which the shares take place, that we should have a exogenated condition for each country in this case. So for every country N, which is where the inflow immigrants is coming from, there's a separate exogenated condition. So that's the pool of different differences. Okay. The other way we can do this is if we assume that the shifts are exogenous. Personally, I think this is a lot easier. You know, in your example, the assumption is like a global oil boom is probably more exogenous to like local factors, because local factors aren't affecting global oil prices unless the country is like Canada.
Yeah.
So that, you know, you have to do some argumentation and thinking here. But they kind of show like in this paper, one of the newer ones, they are showing us how to identify and how to write the validity condition when the shifts are exogenous. Before this paper came out a couple of years ago, the only literature on this assumed the shares were exogenous, and we had no idea what to do if the shares weren't exogenous, which they typically aren't. And then these guys came in and sort of solved our problem. Okay, so what they're gonna do here is, so the main result of this paper is just basically that if your shift is totally random, so you can assume that the shift is just like a random number between 0 and 1. It's just like a lottery, right? So they show in this paper that the average of random shifts, averaged by a share, even if the share is endogenous, you're multiplying it by a random number between 1 and between 0 and 1. And so the product is a random number. Okay, so that's the idea. So there, in words, their result is that the share weighted average of random shifts is itself as good as random, even if the shares are endogenous. And that really helped a lot of us because it doesn't matter if your shares are endogenous, as long as your shifts are exogenous, the combination of the two is exogenous and you're fine. So it makes sense when if I say it in words, we can all be happy, but I think I want to get into a little bit more detail of this because if you can show this in your papers, then it really helps you. And I had to do this in a recent paper of mine. It still got rejected, but I got much better reports based on another paper, which is my counterfactual, where I didn't show any tests. And I think where the literature is right now is I'm coming up with formal tests for how to show the exogeneity of these shifts. I think that, so the example that they give, the example part, the example's not even, I'm going to skip over this example because I think it's more important to show the tests for how these shifts are exogenous. So what we want to do in any practical exercise here, excuse me, sorry, is show that the shifts aren't choosing where to hit, right? That's what we essentially want to show, that these shifts are like being apportioned down in a way that is uncorrelated with the different characteristics of those locations. So if the shift is more likely to affect a place that has a lot of oil deposits, then that shift is not assigned randomly. It's kind of like choosing to go to, the shift isn't choosing anything, but it's like correlated with unobservables in that location. So this won't work out. So what we want to do is find some way to show that the distribution of the shift across different characteristics of this location that you're studying is equal depending on the value of those shares. So a place with high oil suitability or whatever, if you take a bunch of places with high oil suitability, they should have like a nice distribution of shifts. It shouldn't be all clustered in one. They shouldn't all be receiving a really high value of shift. That's the idea. So I thought up a test, and this is an example from my own project, and you may have seen this when I was presenting. But what I was doing in one of my papers was studying how migration affects agricultural outcomes. And shift, and that in our case was destination income shocks. You got all these people living in farming areas, and then far away there's these big wage shocks, and now they're going to leave these farming areas and go chase the higher wages. So that's the shift. The share is the number of males living in these houses who are migrating. So places with more males are more exposed to the shift because in poor countries, mostly males who are migrating. And if there's no males at home, then that family is not exposed to those wage shocks. If there's a lot of males at home, they have a lot of ability to take advantage of that shift, so they're more exposed. That's the idea. Problem, of course, is that if the kind of wage shocks are affecting these male-dominated households more, then that means there's going to be a correlation between the shift and the share. So if places with more like male, if households with more males are more exposed to the shift, households with more males are very different than households with less males in many other ways. And so it's very unlikely that this condition is going to hold, right? Similarly, places with more males, they might be more educated. And therefore, if places or households that are more educated are more exposed to these destination income shocks, then in the absence of that shock, more educated households will be trending very differently than households that are less educated. So this all breaks down. And so what we want to show is that this shift is happening kind of random, and it's hitting these households not based on their characteristics, but based on something that's exogenous. And so the test for that would be to just compare or correlate the shift. So in this case, it's like the difference between the wage shocks in period 2 minus period 1. So that's like the shock. And then these are characteristics of the house. And so if theta is positive, it means that this shock is more likely to hit households with certain characteristics. And then that's not the good thing. So this is basically a balance test. And so we did it. And for the most part, we're pretty good. So this means that like the shock, which is the destination weighted income shock, it's not correlated with the baseline number of males. So households with more males are not more exposed to the shock. And it's not correlated with any of these other things that are confounders. It does look like the shock accrues more to households that are more educated. That's a problem. And so you would just control for education. Yeah.
So I feel like I'm misinterpreting something, but like the basic of your ID or IV was that households with more males were more exposed to the shock.
Yep.
And now we're testing to see if that assumption doesn't hold. Like, do you see why I'm a little confused?
So it's validating, like it's just validating that we can use this as the share.
So like, because our general IV assumption, one of them is that we want the IV to be valid.
Yeah.
Like to have a high predictive power. And in this case, I wouldn't imagine it would have a high predictive power because it's not affecting households with males more. So like, do you see what I'm confused by there a little bit?
Yeah, I do. I think I see what you mean. So there's two things going on. So one is we don't want the shock isn't affecting the share. It's the product of the shock and the share that's together the IV.
Yes.
But what I'm showing in that case is that this shock is not itself like if, forget about the Z,
Oh,
what I'm
I
doing
get it,
is
yeah.
just regressing the shift on the share.
Yeah,
I'm not saying anything about the combination of the two.
yeah,
I'm just showing that I can do this in the first place.
gotcha, okay, yeah.
Because
yeah.
this, the product of this and this needs to yield a Z that's exogenous.
Yeah, so
But
you're,
if this share is more, or sorry, if this shift is more likely to like hit places with like a higher or lower share, and that share is correlated with other things
yeah,
that affect the outcome, then the
Yeah.
exclusion restriction.
so you're essentially testing, does the shift change the share?
Yeah.
Okay,
That's
that
right.
makes sense.
In an endogenous way,
Yes,
Yeah.
yes, okay.
because yeah, that's right.
Okay, yeah, so like in my oil case, the problem would be like if an oil boom caused certain counties to produce a lot more oil and then that screwed up their shares.
Yeah,
then that would
in
of
an
course,
endogenous way, yeah,
yeah, okay,
that's right.
cool. That's actually really cool.
So that means just to follow up on that, so that means that in your case, you wouldn't use the share of educated people
Exactly.
as the share.
Yeah.
But you can use like male or outside or ag household as the share.
Exactly.
Okay.
Yeah, so I'm glad I did this because originally this was my share. Before I did this test, when I first started the paper, I was using the destination like shift. And then the exposure to that shift, I was saying, well, places that are more educated are more likely to send migrants to take advantage of manufacturing shocks because they have the skills. And then I later did this and I was like, oh, dang, I can't do that.
Because essentially the argument would be that like the increase in income allows people to get more educated or something like that.
Yeah.
So that whole, okay,
So the whole system gets
yeah,
disturbed.
yeah, that's super cool.
And but again, if this happens, then you just control for education. Because this would just mean that like your shock affects educated households more. Even though my like males is my exposure, not education, probably households with more males have different education levels. So then we still need to control for education.
Go ahead. Do we have to worry though that there might be, like, in your case, you tested all of these different things. Do we have to worry that there might be a sixth column that we're not testing?
Oh, always, yeah.
Yeah.
Because
okay.
these are like epsilon is all the unobservable.
Yes.
So we can't, this is just like a falsification test.
Yeah,
You can never test the exclusion restriction, obviously.
yeah.
So this is like things that I had in my data set that I could just show the referees, like, listen, this is a pretty good shift share.
Yeah.
The shift is pretty plausibly exogenous. Look, it doesn't disproportionately hit households with these endogenous characteristics.
Mhm.
So I think it's a good one. Obviously, he could have just said, well, what about the crop diversity or what about other things?
Yeah.
That's just. But yeah, the other thing I'd rather show, which I think is more important in case I run out of time, is a different example from the same idea, but this is another kind of trick that you can do to show that your shift is exogenous. So I kind of alluded to it earlier, but if what you could think about doing is showing the distribution of your shift over households with different characteristics. So what this is doing is I'm looking at the share of households that are exposed to the different levels of the shock. And I'm using the distribution for places with high number of males and low number. And so what this means is, for the high number of males, this means that there are kind of a lot of the households with basically it means that there's a normal distribution of the shock across households with a lot of males. You take like households with many males, there's lots of different levels of shocks that are hit. For the low number of males households, it's the same distribution. So that means that the households with fewer males are not disproportionately affected by like a larger shock. Because if that were the case, then for these guys, then we would have a normal distribution over here. And so basically what this is just saying is that there's very similar levels of the shock that are materializing over households with low and high number of males. And that means that this is a good instrument because the shock is not selectively choosing where to hit. They're both hit by the same distribution. So if you can do a histogram like that, I think it helps a lot more than doing fancy regression, in my opinion. Okay. So the last thing that I want to say is kind of an extension that a lot of people are talking about these days, and I'll give you my opinion on why I don't really think it's that important. But a big question that that people have been asking, especially after this paper came out about the shifts being exogenous, is that like, if we're using like a shift that affects employment, for example, and we look at the effect of employment on wages, if there's like a big shift in labor demand, and that's what we use for identification, just because that might mean that there's more employment or less employment in one area, those people might move to a different place and take up jobs there. And so aggregate employment may be totally unchanged. And so this really depends on like what you're trying to answer. So if you're just looking at the effect of like wages on employment or employment on wages, the shift share really misses a lot of important points about like spillovers and general equilibrium and stuff like that. And so that was like a big criticism when these papers came out, is that even though you're using this aggregate shift, but we don't actually get to learn anything about aggregate implications, because we're using the aggregate shift, but then we're just breaking down all the gradation to this lower level. And so if your question is something where it matters, or you're interested in saying, well, my data is at the individual level, like the household level, but is there something you want to say about the district level or the national level or the labor market level or something like that? It gets really difficult because you can't just like average your instrument to different levels, right? Because this is a very particular product of two variables. And if you're taking your instrument, which is at the level of L in our case, which is like an individual or a household or a region, if we take the average over a bigger area, it doesn't make a lot of sense, because you've got the shift at one level, you've got the shock at another level, and now you want to average the whole thing to a third level. It gets very complicated. And so what they do in this extension is to show that whether you are studying your analysis at the level of L, which in our case was a region, you can just kind of flip everything and re-aggregate it to the level of the shares instead. Or sorry, to the level of the shift. Before we had the shift, and then we were like breaking it down to the level of the shares. Now we can start with the shares and basically build back up to the shifts, and then all the identification assumptions remain the same. And it's a pretty cool trick. So what they call it is a translation device, and they say that you don't need to find a new instrument, basically. If you want to study the same question at a different unit of analysis, you don't need a new instrument. You can still use the same building blocks. You just have to put the aggregation, and you can do it. And there's a numerical equivalence result there. And that is nice because instead of studying in the first example, we're looking at employment wages, and then there's like an industry shock. In this case, we can, if we're going to aggregate to the level of the shift, that is an aggregate over all of the different industries. Sorry, over all of the different regions. And so it automatically captures spillovers. So I'm not going to go through the math, but you'll get these like slides later, and you can see it for yourself. But it's kind of it's a very simple, very simple result. And all it says is that if we take the IV estimator of the unit level, which is what we had before, so this is the standard IV estimator, where we got up here, that's the reduced form, the instrument times the outcome divided by the first stage. And we just open this up into its shift in the share. We're just going to shift around some of the summations and do like very standard algebra, and we can get to the same estimator, but now at the level of N instead of the level of L. And and there's a numerical equivalence between the two, and it just means that you can just kind of reaggregate things and study the same question at a higher level and capture spillover. And that only matters if your research question finds that interesting. If you don't care about aggregating, don't worry about this. It's just there in case you want to do it. Don't average your instrument to a different level. Reaggregate starting. You have to build back your shift share and just flip it. That's all this is saying. Yeah.
Yeah, I'm actually using a shift share instrument to look at remote work from home.
Mhm.
As this is really great and interesting I just wanted to ask, is this seminar going until noon? Is that the schedule?
Yeah.
Okay, because, I have the room reserved from noon for my, events.
Oh, yeah, no, we'll be out of here by noon. Yeah. We'll be out of here by noon for sure.
Okay, sorry.
I've only got like 2 more slides. Which I've pretty much covered, in everything that I've been saying, but just for, I think when you start doing the shift share, I think you should kind of think first about whether you're using the share-based approach or the shift-based approach. So really think about how you've chosen your shares and how you've chosen your shifts. Which one do you think is giving you the identification? In terms of like which one has more plausibly exogenous variation? Probably the shift. I think it's really rare when the shares are like random. But think about it, and I think depending on what that is, you're gonna choose one of these slides and then follow it. So if you think that your shares are exogenous, think about why you need to, like I said earlier, there could be other types of shifts that affect your outcome through the same shares. And then you can't do this. So you need to think about what those might be, control for them. Do your balance tests that I was talking about. In this case, like I said, the shift share estimator is the same as pooled difference and difference. So if you can do pre-trans tests within your different N groups, whatever your level of the shift is, that's probably the best test that you can do. If you think your shift is exogenous, same idea. You want to do your balance tests for the shifts. So let's see the ones that I did as an example. Think about whether your shares, you want to do like pre-period, base period, whatever. Sometimes you might do 10 lagged periods if you think that's more exogenous. I think someone brought this up in a previous thing, but there's always this question is what if your shares don't add to 1? That's a very common case. It's okay, just control for the sum of the shares. You have to do that because if the shift is random, it's just like a random number between 0 and 1, and within like a region, all the shares add up to 1, then this doesn't matter. Because if there's like a big shock to one place, that's going to get offset by a small shock to a different place, and on average, the instrument is going to be assigned randomly. But if the shares do not add up to 1, now you have a weighted sum, not a weighted average. And that's a problem because now you're going to have some places with like a high value of the share. And even when you aggregate, like when you take the weighted sum to get the Z, some places are going to have like a positive mean or a positive sum in that case. And we don't know how you dropped the other ones. It just doesn't add to 1. We don't know how those other ones dropped. So there's going to be, by definition, correlation between the Z and the error term. So you just want to control for the sum, and that'll solve the whole problem because now you have a share of whatever values you do have in there. I don't know if that made sense. But it's as simple as that. Okay, I'm just gonna end putting up some resources. These are basically the main papers that I drew a lot of this material from. You've probably already seen them. This one's probably the most important. It just takes all of the literature and puts it in plain English with no equations. Have a look at that one. These ones are econometric theory papers. They're extremely hard to digest. So I would only cite them. Don't bother reading them, in my opinion. Unless you're good at that stuff.